Hello. Now we're going to go and do a little bit more on the calculator than we did on the previous video. Here we say given a discrete random variable x, the probability distribution function, and from now on we're going to call that PDF, assigns a probability to each value of x. We'll see what that means. So let's say Kareen makes 75% of her three free throws, and assume that they're independent. Let's find the probability that she makes exactly 3 out of those 12 shots. All right. Now, we could set up a table like this to find out that to do 3 out of the 12 shots, we could do 12, choose 3, or AP usually writes it like 12, 3. And then the probability of success, we know that's 75. She's going to make 3 shots, and the probability of failure is over here, and that she's going to miss 9 shots. That right there, we could plug into our calculator and get the value here. And when you do a free response section on AP, they're going to want to have this written out. But like everything we do in the class, the calculator has a wonderful shortcut, and it's the binomial PDF. So you hit second vars, just like we were going to do normal CDF and PDF, but now instead going down, let's hit up. There is binomial PDF, and we'll hit that. Now this tells us the amount of trials. So here there's 12 trials. The probability of success here is 0.75. And the x value, we want to see that there are 3 of them. Now if you have the old calculator, when you type binomial PDF, you'll hit the n first, the number of trials, comma, probability, comma, x value. And when you hit that, you'll see that it's a very small number, 0.0035. So the probability that she makes 3 shots is 0.00, was it 0.00035? Yeah, 1, 2, 3, 4. So, so there's a very low chance that she would do that. But we could fill in any other value. Something that she would have a high chance at would be 10. Now instead of typing this in again, we can just hit second enter and modify this last number to 10. And now you can see at 10, there's about a 23% chance that she would make 10 of her 12 shots. And you can do so on and so on until you fill the entire chart. Now what's the probability she makes greater than 7 shots? Greater than 7 shots, you look at this and be like, oh no, greater than 7 shots. We're going to go from 8 all the way to 12. So we can take out our calculator. Now we just need to hammer this out, change this to 12, change this to 11. Oop, I'm going slow. But hopefully you get the point. And you could find all of those values and add them up. But like everything on our calculator, there's a shorter way to do it. The shorter way to do it is something called a cumulative distribution function. Or from here on out, we call that a CDF. This calculates the sum of the probabilities up to each value. So if we have a binomial distribution, say our binomial distribution is big, it's going to come from here, and it's going to have the value that's below that. So what's confusing for students is it looks just like PDF, except for one thing is changed. So if I do CDF, I do second vars. Ooh, I'm going to go to binomial CDF and hit enter. Now, this problem says greater than 7 shots. Greater than 7 shots would be 8 or above. So if I did a CDF up to 7, 15%, that would be, what that's counting for is all of the values from here to here represents 15.76% of the data. So let's say 15.8% of the data. So if this is 15.8% of the data, we just have to take 1 minus that value to answer our question. So there are 84% chance that she's going to get 7 or higher. I guess I should probably write that on the right page. What did I say, 84? Yeah. All right. Now, in this one, we could fill in this chart of doing our CDF all the way up. We knew that at 7, it was 84%. Oops. We can do a binomial CDF up to, let's just change that value to 10. And you can see that that's, oh, I made a mistake here. This was 16. But when we get to 10, it's funny that's a coincidence that happened. But now it's up to 96% at 11. And then once it gets to 12, it should be up at 100% because that's all of these added up should always equal 100%. All right, hopefully you can do your work.